Hello and welcome to Mizora Lean Six Sigma Green Belt series. This is the ninth video in this series and hope you are learning from this. We have updated our content and hope you'd like them. Do share what you think about this change and your recommendations. Also, you can find updated learner's guide in the description section. While we talk about the evolution of statistical control charts, in this video, we will try to understand it step by step, starting with how Six Sigma is applied, statistics, which is the backbone of Six Sigma, the roots of SPC, a bit about Walter Sheward, and the relationship between quality, normal curve, control charts, and everything, and finally concluding with control chart examples. So let's get started. So let's start with understanding how Six Sigma is applied now. By this time, you might already know that it is implemented through different methodologies. There are so many methodologies, but let's take example for DMAC and DMAT-V. DMAC stands for, you would already know, define, measure, analyze, improve, and control, and DMAT-V for define, measure, analyze, design, and verify. We will go deep into each of these areas at a later stage in this section, but for the timing, let's stay with this. While all these methodologies are used, along with these methodologies, we can say embedded in the methodologies are the statistical tools. It can be from a basic fundamental tool, from a central tendency, mean, median, mode, or to most advanced tools like factor analysis, principal component analysis, and lots of process control or process improvement tools. And I know at least about 700, more than 700 tools, which includes lean tools, brainstorming tools, value stream mapping, and so on and so forth. So there's so many large number of tools which Six Sigma uses. Having said that, because of the decision making in Lean Six Sigma, we have to use statistics, and hence it is the backbone of Six Sigma. Let's understand now how statistics is the backbone of Six Sigma. We know that Six Sigma and any of its methodology focuses on data-driven decision making. And to make data-driven decision making, we have to use statistics. We have to use data-driven methodology which can give us the decision in yes or no. And hence it is used extensively across all the projects. For example, measure of central tendency, mean, median, mode, measures of dispersion like range, standard deviation, so many graphs, Pareto charts, and control charts, and so many other analysis as well in different stages across Six Sigma. While we say the statistics is the backbone of Six Sigma, there is one more tool or method in statistics which is the backbone of statistics itself, and we can say it is SPC, which is known as the statistical process control charts. SPC is used extensively in control phase, but the thought process and methodology is embedded across Lean Six Sigma world, and we will understand now how all these things are related. Let's try to understand from where process control chart came. By Carl Friedrich Gauss in the year 1809, and normal curve was one of the probability distribution curve out of so many other probability distribution curves. It's like a bell shape, and it's a shape at the highest in the center, which means that the mean is very high, and then as the standard deviation decreases, it reduces in height slowly. The endpoint actually has the longest tail, but only with very few points. As shown in this figure, 68% of the data is between 1 sigma each side, and 95% of data is within 2 sigma, and 99.7% data points are within 3 sigma of each side. Adding this, we can say that 99.7% of the data falls within 3 sigma each side. That means that is the 6 sigma. If we want to understand how to create a normal curve, and in Excel, or there are different videos available, and I have shared earlier as well how to create an Excel sheet. You can refer to those. We'll share in the link. Let's now understand what is the relation between Six Sigma and control charts. Walter Shewart first identified the relation between Six Sigma and control charts. He had fundamentally two ideas. One, what is the relation of quality and Six Sigma? Second, how to relate all this into control charts. He understood and he shared as well that a process needs correction only when or for those points which are out of control, that is beyond Six Sigma, as shared in the last slide. There is a huge cost difference when we talk about 4 sigma and 3 sigma. Hence, it is advisable to correct any point which is going beyond 6 sigma, that is in terms of the variation. Then he also related this theory to control charts. Let's understand how it is. We have two figures here. It's the same figure, just that the other one is rotated to 90 degrees. The first one is a normal curve, and if you see, it's the same thing, 68% within 1 sigma, 95%, and 99.7%. And on the bottom line, you can see it's 0, -1, -2, -3, -4. And similarly on the other side, 1, 2, 3, and 4. When we rotate this, 0 comes to sort of a center line. It comes to the middle as it was earlier, just that it is now instead of vertical, it is now horizontal. We will use this image and we'll understand how the control chart was created, and that becomes very easy to understand after that. Let's now merge these two and understand what is the relation between control chart and a normal curve. Here we have now the same rotated normal curve along with a control chart. Apologies for the resolution, but this is the best one I could get. So the center line 0, it's represents the center, obviously, in terms of the mean and all. And then we have 1 sigma, 2 sigma, 3 sigma. The only difference here is the lower line of 3 sigma, -3 sigma, is known as lower control limit, and the upper one is known as upper control limit, or UCL. This is the relation, and anything goes beyond UCL and LCL, we say that the process or the point is out of control, and that needs a correction, that needs a root cause to understand what it is, where this point has gone beyond this limit, and how we can improve it further, and how to ensure that in the future, for the same reason, it should not come back. Let's now understand the relation between all these things, quality, Six Sigma, normal curve, and control chart. If we start with quality, what does quality mean? Quality is nothing but meeting the customer requirements, which is defined to a minute details. We call it as CTQs. We'll understand while we are on the define and measure stage in detail. But for the timing, let's stay with this small definition. What is Six Sigma? Six Sigma is a methodology to reduce variation, improve accuracy, which impacts customers, right? And we start with the customers always. What is normal curve? Normal curve is just a data distribution. Important point is it shows us the distribution of customer requirements in a data format, and where are we meeting our goals, where are we not meeting our goals. Similarly, if we talk about control charts, it shows us a detailed view of each and every sample point taken, where are we, what is the trend, and so many things which a normal curve cannot give us. That's why a control chart is used extensively nowadays in different format to understand the process ongoing and then ensure that we have control measures in place while we work on that processes. Let's understand with a very simple example, and that would be for this session. So this is a very simple example of a control chart where we have the data points from a semiconductor manufacturer with dead circuits uh, for each product, let's say in a sample. The important point is everything is within the lower control limit and the upper control limit, but the points after that, which is point number 3 here represented as a red dot, shows that it is out of control and we need to do something on this. If clear root cause analysis with clear action and control plans, so that for the same reason there should not be any product beyond this limit. That's what this control chart gives you, and if you do it regularly on a live data point, it gives you all those areas where you need to work, everything which is beyond control. That's why this is so important, and that's why it is the backbone, we call it. So we do RCA on each of these points, come back with action plans, embed the action plan into the process so that it never occurs again. We will understand more details on each of the sections in the upcoming sessions. Till the time, share your feedback, how you like the sessions, and your questions clarification in the comment below so that we can respond to it. Thanks a lot for the time. Have a great time ahead. Thank you.